Hello dear students, welcome to the course of Database Management System. We are learning about database system architectures. We are using book Database System Concepts 6th edition written by Syllabus Shortcode and Sudarshan, published by McGraw-Hill. The outline of this topic, database system architecture, is we will learn centralized and client server system. We will learn server system architectures, parallel system, distributed system, network type. So this centralized system is run on single computer and do not interact with the other computer system. And it is a general purpose computer system with few CPU and number of device controllers that are connected through the common bus and that provides access to the shared memory. A single user system or personal computer workstation, that is desktop unit, single user usually, has only one CPU and one or two hard disks, and OS may support only one user. So in this centralized system, multi-user system, more disk, if we compare the single with the multi-user system, it has a multi-user has a more disk, more memory, multiple cores, multiple user OS, serves a large number of users who are connected to the system via terminals, often called as a server system. Here is a diagram of central computer system. Database systems designed for use by single user usually do not provide many of facilities that multi-user database provides. In particular, they may not support concurrency control, which is not required when only single user can generate the updates. Provisions for crash recovery in such system are either absent or primitive. Let us say that they may have consist of simply making the backup of the database before any update. Some such systems do not support structured query language and they provide simple query language such as variant of QBE. In contrast, database system design for the multi-user system support full transactional features that we have studied earlier. Although most general purpose computer systems in use today have multiple processors and they have coarse granularity parallelism. We will learn that what is a coarse granularity parallelism. This centralized computer system connected with single bus has a CPU, disk controllers, may have one or two disks, USB controller, that is input output devices, graphics adapter with output display, and memory. When personal computer become faster, more powerful and cheaper, there was a shift away from centralized system architecture. A personal computer supplemented terminals connected to the centralized system. Correspondingly, personal computer assumed the user interface functionality that used to be handled directly by the centralized system. As a result, centralized system today act as a client server system that satisfy the request generated by the client system. So here in this diagram, there is a network. Through this network, clients can communicate with the server. Clients are sending requests to the server and server giving service to the clients. The functionality provided by the database system can be broadly divided into two categories, that front end and back end. So in detail, we have this client server system. We have front end and back end. Back end, you may consider that various programming, that is database storage, manage access structure, query evaluation and optimization, concurrency control and recovery will be handled by the back end. Front end consists of the tools that forms, report writers, graphical user interface facilities. So user can interact with the front end. User don't know about the back end. It is hidden from the user. But security is maintained between front end and back end. The interface between the front end and back end is through SQL or through an application program interface. Here at the front end, we have SQL user interface, maybe a web page, forms interfaces, report generation tools and data mining analysis tools at the front end, like as a interface connectivity to the SQL engine as a backend. So functionality provided by database system can be broadly divided into two parts, front end and backend. The backend manages the access structure, query evaluation, optimization. Standards are maintained such as ODBC connectivity and JDBC connectivity, which were developed as an interface client with server. Any client that uses such ODBC, JDBC interface can connect to any server that provide the interface. Certain application programs such as spreadsheets and statistical analysis packages use the client server interface directly to access the data from backend server. A system that deal with the large number of users adopt three-tier architecture, that Some transaction processing system provides the transactional remote procedure call interface to connect the client with the server. So advantages are given here of replacing mainframe with networks of workstation or a personal computer connected to the backend server machines. Better functionality for the cost, flexibility in locating resources and expanding facilities, better user interface and easier maintenance are the facilities under the client server system. So there are two categories of server system architecture. One is a transaction server, another is data server. Transaction servers, which are widely used in relational databases, and data server, which are used in object-oriented database system. So this transaction server, also called as a query server system or SQL server system. Client can send the request in the form of query and retrieve the data from the server. Transactions are executed at a server. Here transaction is nothing but what operations we are doing in the database, like insert, delete and update, or a query we can fire to retrieve the data as according to the conditions. Result are shipped back to client. When user is giving query to the front end will connect to the back end and the data get retrieved at the front end. Requests are specified in SQL. The structured query language format is used to the communication between client and server, that communicated to the server through the remote procedure calls. A transactional RPC allows many RPC calls to form the transactions. Open database connectivity and JDBC standards are used as a C language application, that ODBC C language application program interface standard from the Microsoft for connecting the server and sending SQL request and receiving the results. So transaction server process structure. It includes the server processes, log manager processes, and database writer process. Server process nothing but it receives the user request or queries in the form of queries, the transactions, execute them and send result back. A process may be multi-threaded, allowing single process to execute several users queries concurrently, and typically multi-threaded server process. About log manager we will see, and database writer that doing the output modification buffer blocks to the disk continually. Log writer process. This process outputs the log record from the log record buffer to stable storage. That we have learned about. The stable storage is a backup facility. A server process simply add log records to the record buffer in shared memory, and if the log force is required, the request log writer process to the output log records. And the checkpoint process perform the periodic checkpoint records, that is backup and recovery failure. We have learned about the checkpoints. Processes monitor the process, one process monitor the another process and takes recovery actions if any of other fails, aborting any transaction being executed by the server process and restarting it. A diagram is given about transaction system process, user process at the top, and connected with the servers with the JDBC ODBT connectivity. Again we have here buffer full, query plan cache, log buffer, log table, process monitor process, log manager process, database writer process, checkpoints, log writer process, log disk, and all these front end and back end connected to each other. So in the transaction system process, shared memory contains the shared data, buffer full, log table and log buffer along with the cached query plans. All database process can access shared memory with the help of mutual exclusion. To ensure that no two processes are accessing same data at a time, need to maintain the consistency, that in operating system we have learned about the semaphores and mutex. Atomic instructions such as test and set, that to avoid the overhead of the inter-process communication for log request and grant, each database process operates directly on the log tables instead of sending request to the log manager process. Log manager process is still used for the deadlock detection. Another type of server is data server. It is used in high-speed LAN in cases where the clients are comparable in processing power to the server. The tasks to be executed are compute intensive. Data are shipped to the client where processing is performed and then shipped result back to the server. So this architecture requires full backend functionality at the client, and the issues with this is page shipping versus item shipping, locking, data caching and log caching. So page shipping versus item shipping, a smaller unit of shipping implies more messages worth prefetching the related item along with the requested item. Page shipping can be thought of as a form of prefetching. So what is locking? Overhead of requesting and getting logs from server is high due to the message delay, and grant request lock requested and prefetch items with the page shipping and transaction is granted lock on the whole page. Locks on prefetched item can be called back by the server, written by the client transaction if prefetched item has not been. So lock on the page can be descalated to the locks on the item in page when there are lock conflicts. Locks on unused item can then be returned to the server. So data caching and lock caching in the data server. What is the data caching? Data can be cached at a client even in between transactions, but check that data is up to date before it is used. Lock caching means lock can be retained by the client system even in between transactions. Transaction can acquire cache lock locally without containing the server, without contacting the server. Server callbacks locks from the client when it receives a conflicting lock request. A client return lock once no local transaction is using it. So thank you very much. Next time we will see parallel system.